Okay, this is our next installment on the GalgoMoto quick shifter that we are developing. And this deals with a new feature that's going to be added to the 4.1 version that'll be out in a month or so. And it deals with a problem. The problem is in the strain gauge sensor. The strain gauge, which requires a Wheatstone bridge to generate a very, very small voltage differential that is measured, it's about plus or minus 3 millivolts, is measured by the quick shifter, and that's how you set the preload pressure and the shift point on the unit. And the issue is how do you balance the Wheatstone bridge for slight variations in lead length, temperature, and actual variations in the strain gauges themselves. This is how the strain gauge appears, the strain gauge bridge appears in the shifter. You have a fixed voltage supply, a fixed resistor, a strain gauge, and this RV, and I'm going to talk about RV in a minute. Generally, to balance this thing, you would like to have about 0 voltage differential across the strain gauge bridge. But that's difficult to do, and it's time consuming, and you have to trim it by hand by changing and adding and different resistor values here. So that leads to the question, how do we do this in the field if a customer wants to change a shift sensor in the field? It may be slightly different than the one provided. Well, this is a really neat solution, and what we're going to do here, I'm going to show you a demo. We have a test setup right here, and the test setup is simply 2 resistors in parallel and another device which is a digital resistor, and that's what this thing is right here. And it can be controlled, its value can be controlled by the AT328 microprocessor in the unit. And so this is the test setup I have right over here. Let's go take a look. All right, okay, so now we're going to do a little demonstration. You can see this is the microprocessor that's running. This is the digitally controlled resistor. And this is my simulation right here, the 2 resistors that I've got in parallel that I showed you right here. And I'm going to switch one of those resistors in and out to change the output voltage. Now, this thing can never be perfect because the digital resistor only has 100 steps. So what we have selected here is a desired output voltage between 2.2 and 2.7 volts. You'll see right now we're running right about 2.7 volts. Now let me do this little trick right here. Pull that out and you can see the voltage drop. But guess what? It is self-correcting up to 2.2. And we will put it back in again and let it go to 3 volts. And it's going to correct itself down to 2.7. And there it goes. And as you can see, you can watch this little LED I put in as an indicator. When it comes on, it is in the correction mode, and when the LED goes off, it has reached set point. So there you go. We're adjusting automatically between 2.2 and 2.7 volts. So this will allow the customer to basically plug and play a strain gauge sensor in his unit. And as soon as the bike is turned on, this automatic calibration takes place, and you see it only takes just a few seconds. Then it's locked until you restart the bike. So every time you restart the bike, it will recalibrate. And that's also a handy feature in case the strain gauges over time start to drift a little bit due to age and actually work hardening of the strain gauge substrate. So there you go. That's a neat feature. It'll be on the new 4.1 version.